let me get set up for our next and the only agenda item for this virtual class session. Oh, wait, I forgot to talk about these two, but I think it's fine. It's my usual point. Oh, I've done all the questions here. I go through this check every single time. I have these questions and I have these videos. I compare them. I look for notes. Does it say any mistakes that need to be fixed? Don't see it. So good. Think with that. And if there were real-time person here, then I would have stalled for long enough so that there's opportunity to follow a question if there are any. But not seeing any. We will start with the problem solving with the ChatGPT O3. Wish it were O1, but this is the kind of downside of relying on external service. They make us changes mid-semester. I just have to change with that. So we are going to use ChatGPT in an academically honest way as a kind of a virtual tutor. And this is a use case that I will be frank that I didn't quite imagine that happening when ChatGPT was it 3.5 or 4 first came onto the scene. I thought, oh, this is typical B minus student. I'm never gonna trust it to have correct physics, but I will tell you with the updates in the last couple years, it's gotten a lot better. It's able to answer difficult modern physics questions with a fairly good accuracy. The only thing it still can't do is drawing any kind of diagram. So if you wanted a space-time diagram, it can't draw it for you, but it can describe it. And if you have questions about what you've done, like you thought you did everything correctly, but the system keeps telling you got the wrong answer, then I think ChatGPT can be good as a virtual tutor that can provide instantaneous feedback for you. Now, I still contend that I'm the better physicist and possibly better physics instructor even. But hey, if you're working on homework questions at times when I'm not available, not my office hour and not regular business hours. So if you do ask me a physics question during regular business hour, I check my email almost constantly. And any serious physics questions, I try to answer them pretty quickly, like within a few hours, or basically next time I can get to a computer, which is usually within a few hours. But even that's still a delay of a sort. So if you want to try ChatGPT as a way to get an answer that's almost instantaneous, hey, I have no issue with that, because really sometimes, not sometimes, oftentimes, maybe even majority of times, that's how people learn and retain material through interaction. Whenever I'm trying to remember something, I need to tie it to some context, and discussing a concept with someone or something can definitely be that. So, with the problem set 11, the problem set due on Monday, let's work through this set. I'm kind of play acting a student who may be struggling with the material. I'll kind of, switch back and forth how much I'm struggling. Did I even crack open the textbook, or, did I read it through, put in the effort? But it is a challenging question, so it's taking me a long time. So let me do that. I think starting with the problems at 11, there might be a fairly substantial questions. So so yeah, this is actually a good question to ask ChatGPT. So let me give this a try. I'm gonna start with my usual prompt because I don't want to waste this question. So I'll say, "Hi, I'm back to work on um, uh, my quantum mechanics homework. Um, and because I'm working on questions that I really need to learn how to do in front of my instructor at the one-on-one meeting, I want to be sure that you won't give me the answers right away. Please just help me with the step I'm stuck with, and just give me hint to get it through. Let me get to the answers myself. Unless I ask you, I don't know, 3 times for the answer. Can you help? I don't know how that particular instruction will play. I don't know. I've never tried it before. So, with this question, so this is what I can try. Let's say you don't remember the modulus operation when dealing with the complex numbers. So, what you hopefully learned from lectures or elsewhere, and hopefully remember is that when you have a complex number and you're calculating its absolute value squared, it is different from simply taking it and squaring it. Now, with the real numbers, it's the same, but with the complex numbers, it's different. And the way it's different is this is defined as the complex conjugate times complex number. But let me imagine someone who basically never heard of complex conjugate. Like even if you saw this kind of thing on a website, you would still be lost because you'd think, what is that asterisk? I'll just, do G times G. And if you did that, this is what you would get. You would get, all right, you got f of x of y squared. So you say, all right, x minus iy divided by x plus iy. You square it, and squaring it, you get, x squared, the cross terms, minus 2ixy, and then it's a plus I squared, so it's a minus y squared. By the way, this is all wrong. I'm going to get on the wrong answer, and I'll try to get help from ChatGPT on my basically missing math knowledge that I ought to have. So x squared, cross term, so plus 2ixy, and then this plus I squared is actually saying minus y squared. So I don't think any of this really simplifies. Yes, simplify the expressions you get. So I'll do x squared. Wait, need a parenthesis. X squared minus 2 times I times x times y minus y squared divided by, it's giving me syntax error because all these variables are not defined. Because when you simplify the whole thing properly, you should just get one. But let me get on a screen that says wrong answer, and then ask ChatGPT. So okay, I tried a few different answers for this question, and I'm not getting it. I'm even getting what they are calling syntax error. What am I doing wrong? And I do think ChatGPT as a virtual tutors can be really useful. Basically, filling in gaps in what you maybe didn't learn in prerequisite math, or maybe if you did learn, you forgot it. And this is the kind of thing about missing topics, which is it can be really hard to search for. Like, how would you search for expression like absolute value squared? That's gonna result in so many hits that has nothing to do with the complex numbers. Maybe you can, craft Google keywords better and get a more usable result. But you can also ask ChatGPT as a virtual tutor. So let's pause for a second, make sure right quantity. Want that modulus square? Yeah, it's distinguishing modulus squared with the just regular square. So let's see, hint one. Right and for okay, so you could kind of slow down and do that. Let's say you just never heard of modulus, you have no idea, and you keep reading. We're in two complex numbers nicely with the division. Okay. I see, I see. So you can do modulus of the whole thing. That's what it's saying. Or modulus of the top and bottom separately. Okay, you could do that. Do one modulus explicitly. Oh, that's interesting. That can be something I can take on and try to treat x as a real part and minus y as the imaginary part using into one. What is? That's interesting. Let me ask you this. I don't get what you mean by um, are you saying absolute value x minus iy squared is equal to x squared plus y squared? Because I get x squared minus 2 times I times x times y minus y squared. Just playing a little lost. Double distance ordinary square, yeah. Then modulus squared, and it's telling you this, yeah. Yeah. So complex conjugate algebraically multiplies away the i's. Yeah, it does. Now, I guess from this much example, you might be able to figure out what complex conjugate is. It's simply the same complex number with the imaginary part just turned into imaginary i's turned into minus I. And if A and B were somehow complex themselves, then you would put, complex conjugate to A and B as well. But if they're real, then, complex conjugate does nothing to that. Uh, okay. So let's say I claim this. Uh, okay, this is new to me. Um, and math expressions don't really copy and paste well. That's why I'm having to do all this. Here, G is okay, this is new to me. What do I claim? What is a complex conjugate? I wonder if it'll explain. The process of getting complex conjugate and maybe even meaning of it is a mirror image of a complex number across the real axis. Is it? Oh, I guess it is. Because the imaginary part will be y, so you flip it that way. Then, yeah, I guess yeah. Any conjugate is that. Keep the real part. Yeah, flip the sign of the imaginary part to be, or basically replace every I you see with a minus I. That's more useful in cases where you have more complicated looking expression that doesn't have real and imaginary parts separated like this. Y matters. Yeah. Okay. Absolute value x minus I y squared is equal to x squared plus y squared. Uh, and let me give a confused answer for the next one. Okay, I don't think that's right because I get x plus or minus. Yeah, plus iy squared is equal to x plus iy, x minus iy is equal to x plus y squared. Those two shouldn't be the same, right? And they should be the same. I think the representation difference between these would be this x minus iy would be going like in the fourth quadrant, 45 degrees. Plus iy, assuming x and y are the same. X plus iy will be going like 45 degrees in the first quadrant. Yeah, they are identical. Yeah, sign in front of it doesn't matter. Yeah, the distance from origin. Slot those into result. Device provide zero. Extra dumb. Uh, it should be one. Extra dumb in the sense that it mentioned the x equals y equals zero, and just repeating. But ChatGPT will be very polite to you. It will never call you dumb. It'll tell you you are close when you gave zero for an answer that should have been one. So I'll say, I got it. I got it. And I guess I can correct it here. So to correct it, I think I have to basically do it this way. Absolute value squared. So get rid of this, plus is equal to 1. Um, yeah, good. All right. Thank you. That was long for one question. But with the quantum mechanics, I will share my experience taking upper division quantum mechanics. My first year in university, I felt really lost, and the part that took me the most amount of time was learning all the notations, because I think in my lower division community college class, really the one thing that I wasn't taught properly were all the notations. And the lower division textbooks don't do a good job of teaching you all the important notations, right? So now, if you struggle with the notation the way I am, role playing right now, then virtual tutor like ChatGPT can be really helpful. Because the challenging thing about notation, I mean, so I guess back in my day, Google was around, but it's like, how do you even Google search notations? They are all weird characters. They are not like typed words. But ChatGPT can take an image and give you feedback based on image. So yeah, good. All right, so I think I want to end this session a little bit early, so we probably have another 20 minutes to go. Let's try to pick a couple questions that could be challenging and answer. Um, so we fixed up this question, but maybe I can do this. So let's imagine I make a slight mistake with the normalization. So normalization condition, maybe you do remember it correctly. Absolute value psi x squared dx is equal to 1. That's your normalization condition. So a wave function of a particle that can move along the entire real axis would mean basically you have to keep this number finite, so that you can set a normalization factor that'll I can write infinity. You can set a normalization factor that'll be, it will bring the whole thing equal to 1. Now, as you look at it, so think tangent of x is super ill behaved. There are singularities all over the place, so that you don't check that. Exponentials die off pretty quickly, so you might think, all right, that's 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 normalizable. So it can be a particle that can move along the entire axis. And this, maybe you are clever enough to remember that when you are trying to integrate this from x equals negative infinity to infinity, you realize when you plug in negative infinity, this thing blows up, so you can't normalize it. Maybe you remember that, great, so you don't check this. But the one with the absolute value was fine. One with the squared is also fine, you check that. And then you look at this and you, I don't know, have a brain fart. And just to remember that, oh, my 1 over x from 0 to uh, infinity, that actually blows up. It goes to infinity. It's one of those, is it called the harmonic series? It blows up to infinity. So you don't check that last one. And so then you should get a partial credit for that. Yeah, we didn't fix it. In fact, I think this might have been an errata in the OpenStack solution that we submitted a while back. So you ask ChatGPT, like, what am I doing wrong? Now, I guess if you only care about the correct answer, you could, by trial and error, figure out this is the answer. But let's just ask ChatGPT. So I thought I carefully calculated the integrals to make sure even tangent x, make sure that the integral for the functions I picked would let me make the chime thing. um, and let me just put this in the chat. Um, that the integral for the functions I picked would converge, and I can normalize it later. Uh, but the system says my answer is partially correct for me. What did I miss? And what I missed is, you gotta square it first. It's the absolute value squared that should be normalizable. So, if I do this integral, yeah, that'll blow up. But the squared version won't blow up. Now, I don't know if ChatGPT will get it. It's, there's a lot of stuff on this image. I'll be very impressed if it correctly spots that I should have checked this. And maybe even if it points out what the mistake in this expression is. Maybe it will, maybe it won't. We'll see. Those thinking 47 seconds, yeah. Well, that are normalizable. One more hiding in the set. Worried about twice at t. Yeah. Wow. Yeah. I think it got everything. Sine squared isn't, yeah, is 1 over x. 1 over x is squared. Yeah. So, I mean, I still have that divergence, but not what I should be worried about. Yeah. 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 This actually converges. Yeah. So, yeah, wow, that is impressive help. Again, that's why I'm saying I think I can recommend using ChatGPT as a virtual tutor. Uh, so I'll just say, oh, I can't believe I missed that. Thank you. Good. So I was saying just before our real time person joined that I might cut this session short to maybe end around the 2:45. Let me at least end the recorded version at 2:45 still. And if there are questions, I'm happy to answer those. Uh, yeah, yeah, yeah. And can I find this errata? You know what? Let me do this. I'll come back to this at the 2:45 mark or so and show you the errata that we filed. Because I think there was an actual error in the solution manual itself. It was not just one person's error. Um, so let's see. Uncertainty. Oh, that feels easy enough. You just apply uncertainty principle, make sure to divide by mass of the particle. Let me see if there's a more substantial question. We probably have one or two um, substantial questions we can do. Let's see. This I think it's a tutorial. I'll have you do it. I don't think this is still the case. So you can there's a Unicode H bar symbol, but since that's almost impossible to type, I'll just have you spell out H over 2 pi for all the H bars that you would type in if you could, but the system doesn't recognize it. Let me find another. I think this is the same thing. Yeah. See, suppose a particle with a mass. Um, Stationary Schrodinger equation. I'm just trying to see. Um, yeah, I guess I'm not doing anything interesting with um, the like traveling wave and all that. Yeah. Yeah, it's fine. From the fact that the we are using the real function, there wasn't any difficulty here. Although, like in written in this form, the coefficients a and b don't really have any physical meaning. You can't say it's amplitude or something traveling to the right or traveling to the left. So, use a complex exponential. That's the more natural representation. Um, this is infinite square wall, which could be good one to kind of make mistakes on. Um, One-dimensional box. I think this is about the same level of difficulty. Um, to excite first, this could involve more steps. Um, let's give this a try. So, um, let me imagine someone who's reasonably competent, but they make a tiny mistake. So electron confined to a box, great. So you immediately recall, oh, this is an infinite square wall problem. So you have a V going to infinity at the edges, and and it so it talks about the longest wavelength that is registered. Oh, let me draw wave function solutions here, by the way. So that's first level. Second level would look like this. The third level. I'm not spacing them quite correctly, but it's fine. Longest wavelength that is registered, and maybe you remember even something like this. Let me do the things um, that'll give confuse me and give me wrong answer. You remember de Broglie relationship that momentum is equal to h over lambda. And looking at these solutions, you realize that um, um, you realize that for this longest wave function solution, so this should be L, and that if you extend it out to give you the one full wavelength, then the wavelength here is lambda is 2L. So you think, all right, longest wavelength is 2L is 570 nanometers. So you plug in L equals 2, this is my trap, 85 nanometers. Let's see, double it and you get 570. Okay, good. I calculated it correctly. Now it'll be wrong answer. And let's say you're just confused. Like, I thought I did everything right. I had the right standing wave representations. I picked the longest one. I did all that. What am I missing? And what you're missing is, it's talking about wavelength of photon. So it's talking about wavelength that's associated with the quantum transition, quantum transition between levels, not the literal size of the box. Um, I'm not sure what I did wrong here. Technically, I'm not asking any question, but ChatGPT is intuitive enough. It'll kind of give me a response that's consistent with what I have instructed it. It'll hopefully recognize that I'm stuck in some step and give me some hints to help me break out of that stuck steps. So the first thing I think it should tell me is recognize that the wavelength that the question is giving me is not wavelength of the electron, it's wavelength of the photon. Yeah, so yeah, check the physical picture. Yeah, that's great. That's great hint. How the photons come out in an infinite square well? Oh, okay. Yeah, you can look it up from textbooks. So, all right. Now, here and then don't jump the gun and just do the other thing. Photon is emitted when an electron makes a transition between two levels. Yeah, so it's energy difference that you are looking for. So longest wavelength, smallest energy gap. Yeah. So because of this relationship from HF, the first quantum assumption that we introduced, the largest wavelength means the smallest delta E, so smallest energy gap. So uh, sure, yeah, I gave me the answer here. Maybe giving me a little too much help. You might want to kind of read line by line, and after you read this question, don't read ahead. Just think about it, write something down before you get this correct answer, because otherwise you might not remember it. Set up the equation. Okay, you should find. Is it just giving me all the answers? Um, I mean something like maybe. Um, I mean, do I get that? Let me just give it a try. Let's say I'm someone working through this in good faith. I'm trying to read all the hints and actually go through it. So, I have E of n. Let's say I trust ChatGPT's given formula. I'm not even comparing it against the textbook, which I could later, but I probably won't. It has me calculating it. Oh, I see. It's from 2 minus 1. So I think this 3 is coming from 4 minus 1. Somehow I thought it might be doing a general thing. Well, then on that, um, so let me ask this. In hint 3, where is the 3 coming from? Oh, that's a very confusing question. Am I asking about the 3 in hint 3? Or am I asking about the 3 in the expression for energy? Let's see how ChatGPT answers that. Yeah, it correctly understands that the 3 is not in reference to the ordinal, yeah, ordinal of 3. It's, talking about the 3 in the expression. Yeah, yeah. So, yeah, 4 minus 1 gives you that 3. Yeah, good. Um, so it's still exact. It's not approximate or anything. Um, so, all right. So you understand hint 3, hint 4, solve algebraically before plugging numbers. Yeah. So you just have to solve this for, not that, but, the one with the 3. You just have to solve this one with the 3 for L. So you can just, uh, L is equal to square root of move 8 and over 3. Oh, actually, like it's no more n. I've actually plugged in n equals 2 and in n equals 1. The difference is what gave me 3. So 8n, the en, which earlier hint said set it to hc over lambda, delta en. Yeah. And hc over lambda is the energy of the photon. So hc over lambda times 3h squared. 3 times lambda h squared, some factors of h cancel. So 8mc over 3 lambda h. 8. Oh, wait, I did it wrong. Sorry. Yeah, I think continuing on that mistake might be too much because L is on the numerator, so I actually have to move L over there. Or I guess here what I have done is I've actually solved for 1 over L. So you can say L is equal to square root of the reciprocal. 3 times L H. I canceled the squared already. A M H C. No, I canceled H already. So just A M 8M C. Let's compare that. 3h lambda max divided by 8mc square root. Yeah. Okay. Um. Oh, that'll just give me. Oh, I can use from alpha. What mess are we using? Now you can technically just read the question or read this response and do that. But let's say you are just being lazy. You didn't read the electron. You are thinking, is it electron or proton? Without having read. ChatGPT should point out, question says electron. Use electrons rest mess. Yeah. Yeah. So I will plug it into Wolfram alpha and get square root of 3 times the wavelength, 57 nanometer times Planck's constant, divided by another square root of 8 times. I can do it that way. Somehow felt easier to me. Electron mass times the speed of light. So I get 7. Oh, let's try this. So if I look at this and simply put in 720.2, it'll be wrong because it's answering picometers. I need an answer nanometers. So after having gotten the question wrong, let me see what ChatGPT says. Okay, I got an answer of 720.2 with a Wolfram alpha, but the system still says the answer is wrong. Errata? And just trying to confuse it. Um, I mean, if you do find a mistake in the question, do let me know. I'd love to fix it. But I've spotted a lot of mistakes through the past 2 years when we had people taking this class. So I do doubt that there's many serious errors remaining. Is it still analyzing or oh no? Take a very close look at the units. Yeah, unit conversion picometer, meter. Yeah, it's the same length because yeah, when you keyed, yeah, you off by a factor of 1,000. Ah, that's great. It's spotting all those issues. And yeah, it's a good virtual tutor. So, all right, that's probably the last question I'll do. I don't think there was a more kind of substantial question, but if you get stuck, again, this is what I'm demonstrating. You can kind of feed your work into ChatGPT, have it give you feedback, exactly correct the mistakes that you may be making. So before I, end the recorded the portion of the virtual class session, let me just go hunt down that errata, just out of I don't know curiosity. So it's this question. Um, I'm trying to figure out if there's an easiest way to get question. Yeah, all right. I don't have any easier. I do have to go in with my instructor access. Although maybe I can do this. I can just search. Uh, then I don't display anything that's ID all libraries. Uh, is it just ID? Oh yeah. So it's so this is the errata we submitted. Okay, I don't have to actually search. Yeah, so revise A and E can be normalized. Yeah, include this option, which was the incorrect because can be normalized as well. Yeah. And the mistake, I'm sure both the original answer key writer and one of my colleagues, and I think I was making the mistake originally. I think I caught this when I was doing one of these sessions, I think. The reason I realized was, oh, right, you are not normalizing the wave function. Like, you are not doing the integral with the wave function itself. It's a wave function absolute value squared. So the 1 over x thing, not an issue because it becomes like 1 over x squared. All right, so I think that's everything. Or everything I want to do. Let me say goodbye to people joining by recording the video, and I'll stay online briefly in case our real-time person here had any questions. If no questions, I'll just end early and finish up those videos I was talking about at the beginning of the session. So bye to people joining by recording the video.